So let's go. Just try to. Yeah, can we minimize it? Don't see it. Okay. So to start again, on the Cola Web, it's about, starting to take a look at the research data and the research activity at Georgia Tech, but really focusing on the people that do the research, right? That people centricity. But it's also about, not just focusing on the data and visualizing the data, but also focusing on generating knowledge. What does it mean to have knowledge about who does the research at Georgia Tech? So this is kind of, how we challenge the student, and the student embark in exploring a concept called enterprise knowledge graph, EKG. And no, EKG can be a medical term, but in this case, it's really focused about knowledge graph. So you have an example on your right about, the structures of a knowledge graph. And, you can do a knowledge graph on a piece of paper, just, about some circles where each circles represent an entity. In our case, we have in the case of research, we have different type of entities. We have works, which reference the published papers primarily, but it can be other type of research output. It can be, in the futures, preprint articles. It can be also the master thesis or the PhD thesis from grad students. Anything that is research related in terms of research output. You also have the authors, right? This is really the people who does the work, who does the research. You have the concepts, meaning if you have, for example, research output with even, published papers, what is the research domain? Is it math? Is it artificial intelligence? Is it about differential equations? So on and so forth. But also institutions, right? People that do the research work at institutions, or they're part of an institution. So you want to have that affiliation. You could say, well, this may be an interesting concept, a graph, and yes, I can do it on a piece of paper, but this is not very different from using other type of data structures like a SQL database, right, relational database. And that's right. However, we kind of challenge the student to go that path because knowledge graph have flexibility in terms of you don't have a predefined strict schema. And so as you discover data, as you discover new entities, you can just add new entities and you can create new relationships and add properties to this relationship. So you have a certain flexibility, particularly to capture relationship between entities. So this is a work that has been happening. At the bottom, you have kind of a quick sample. This is part of a snapshot of the graphs that the students have been building using an open source data set, which is called OpenAlex. That data set is actually the successor to something called Microsoft Academic Graph. So the students have been focusing on the people, the authors at the centers of the graph. And then you can see that, as a snapshot, you have, for example, they have looked at relationship between institutions. Georgia Tech is an institution. UGA is an institution. So are, University of Michigan, right? Any university is not just R1, but any institutions where you have research happening is going to be listed. And what's interesting is that they've been focusing to the fact that someone publishing a journal paper may have a current affiliation with an institution, meaning working at. We have today grad students, faculty, research engineers that are currently working at Georgia Tech, but they also have published papers and are no longer at Georgia Tech. And so this is a worked at, which is interesting because someone is no longer at Georgia Tech, they still have that relationship we want to know as part of an analysis. So this is a very quick preview of, a snapshot of what the students have been looking at the graph. Well, we talk about enterprise knowledge graph, we talk about relationship, we talk about entities. Sounds kind of fancy, but how does that help us? If we want to talk about people centricity, if we want to talk about knowledge, how do we use that? So these are the kind of questions the students have been trying to answer using a knowledge graph. One of the questions is, whenever a grad student, whenever a researcher or faculty is working on a paper and publishing a paper, they are collaborating with others. Now, could we find who are the top 10 researchers at Georgia Tech that have the most outside collaborators? Meaning, if you look at the set of all of the published papers they have worked on, and you look at all of the people they have collaborated, who has the most of external collaborators? And so this is the list at the top, right? You have this name of 10 faculty that when we look at the set of all of the external collaborators, they are ranking towards the top 10. How does that help us? Well, it can help us see who has the most collaborations, but you could also ask the inverse questions. Who are the researchers, maybe tenure track faculty, who don't have a lot of external collaboration? That could be interesting to know. So some of these names, you could probably recognize them or guess these names based on other sources of data, such as Google Scholar, but it's a way to start now to gain insight. Another question, which is probably not well explored yet, is, researchers, starting even with grad students, they may start to work at Georgia Tech, do a master thesis, do a PhD, and publish papers, do research, but then move to another institutions. And it's interesting to kind of, see where they go, right? The same way, we have a lot of faculty researchers that come at Georgia Tech from other institutions. And so, when we look at the set of researchers that currently are working at Georgia Tech or have worked at Georgia Tech, what other institutions have they also worked at or are currently working at, right? Kind of trying to do that intersections. And so we have some of that data. That question led us to understand that we had issue with the data sets. Because if you see the number of top, institutions, it's not an institution, it's actually a department at Georgia Tech, which is shared with the university, with Emory University, which is a biomedical department. So it's normal to see that department being toward the top because a lot of faculties at Georgia Tech that are part of BME have an adjunct status at Emory University and vice versa. So this is where we recognize that there is issues with some of our data. And I'll go back a little bit to that. But we do see, additional insights, such as, you have Oak Ridge National Lab, you have Pekin universities. So it's an interesting way to look. But let me just go back quickly to the previous slide, because now we touch on the challenge of the data. No data is always a clean data set. And so as our students were looking at the graph, they got to learn that, a lot of time and energy has to go into preparing and ensuring the data set is clean. And they had to learn some challenges such as disambiguation. Oh, what a fancy word, disambiguation. But the reality is when you get data about published journals, sometimes you come across there is not a good way to distinguish people as being a unique individual. And so if you see two people with different identifiers and their names are Lou Lofton, are they the same Lou Lofton or are there two separate, distinct Lou Lofton across the world that have published papers? Not every people with the same names are the same, right? And so this is what introduced the students to research this topic of disambiguation. Given a list of people, how do you recognize they are the same people or they are distinct people that just happen to have the same names? It also exposed them to, the importance of having these digital unique identifiers, ORCIDs. So to kind of move on to the last piece is, as the students built this graph, as the students started to now learn how to ask questions from the graph, came the issue of, well, how do we expose this? How do we make this available to any users? One of the way is to focus on visualizations and maybe providing an interactive way for people to interact with the graph. Sounds good on paper, frankly speaking, except when you look at the previous question of how do we find the top 10 researchers at Georgia Tech that have the most external collaborators, when you look actually at the graph, you see this kind of web. I mean, it kind of looks like like a stars, right? Where at the center you see this tiny blue dot, which actually represent these top 10 faculties. But it's very difficult to interact with the graph because they have so many external collaborators that you have this myriad of red dots with all of these relationships. It's like, that's not going to work. So this semesters we have students that are looking at, well, there is this new technology. You may have heard it, right? It starts with a C, ends with a T. It's called ChatGPT or generative AI. And obviously you put AI and students in the same sentence and they're kind of attracted together. And so they are looking at how can they use basically generative AI to maybe simply ask the questions from the knowledge graph, having the knowledge graph being the source of truth. And rather than the end users basically looking at interacting with the graph, simply typing the question. Now, this is very ambitious, but this is what it's about with VIP, is having the students taking ownership of the project and exploring. And with that, I'm going to turn it to Andre for the next project.
Thank you, Didier. All right, so I'm Andre Goodman. I'll talk a little bit about what we're doing with our students as it relates to student data. I work in OIT as leading the enterprise reporting team. And so I spend a lot of my days looking at data from all parts of the campus. And so when I first signed on to the course, I was really excited about working with the students who are really interested in creating reporting, dashboards, applications that help them make better decisions about the kind of courses they want to take, uh, what type of classes they should be taking, when they should be taking them, and kind of centralizing many of the academic resources they need to make those decisions. And so one of the user stories that they had was around a provost dashboard. I think they called it that because they wanted to bring a lot of attention to it. But I think it's a great name for that team because they're looking at trying to take on a lot of different aspects of how students engage with their academics. So they conceived of a solution where they could have a platform that sort of brings all this data together. And I'm excited about it because a lot of times when I look at this VIP course, I look at it as an opportunity to do some work on our behalf, some R&D, if you will. And that effectively allows us to sort of kind of take what they build and sort of create something out of it. I've done that in the past when they've helped us with some of our research dashboards. They've kind of conceived of different ways to look at stuff, and then we've taken that and tried to operationalize that. So let's talk through some of their actual, their processes. So first and foremost, in order to get started with this Provost dashboard, they needed to start asking questions from actual students. What are some of the things that are you most concerned about? And when they did their survey, obviously came back registration info, knowing if a class has a wait list, am I going to be able to get off that wait list? They want to know more about campus organizations, study abroad opportunities, and of course, costs associated with being a student. So they have gone through and tried to start looking at low hanging fruits, right? And one of the things that I love about this team is that they're incredibly ambitious, and so they have begun building out wireframes around what they'd like to be able to interact with as an actual student. And so they've actually designed this themselves, wholly conceived by the students. And they're working with us to figure out how do we operationalize this? Do we use APIs? Do we build this in Tableau? Do we use Tableau's API to port this into an application like React? They are very ambitious, and I'm excited about how we can potentially take this and actually operationalize it. And so this is a really great team that is probably one of the biggest teams in VIP because the students are really excited about the prospects of being able to sort of create something that can help them as well as future students. So with that, I'm going to switch it over to my colleague Emily to talk about ideal course mappings.
So this dovetails really nicely. So a lot of students are concerned about what their GPA might be, when they might graduate. At the same time, advisors are concerned with when are you going to graduate? What's your GPA going to be? And general like wellness ideas around getting the courses when you need them, being able to successfully complete them, and then plan for the next steps. And so one thing we've been thinking about is course mapping, and we call it ideal course mapping to kind of differentiate it from the idea of course mapping that's already done. So we know in a lot of places course maps are done to kind of show prerequisite chains. So you have the first chemistry course that leads to the second chemistry course, and so on and so forth. And so you get an idea for where are the stop gaps going to be for people getting the courses that they need. What are the courses that are going to be in higher demand or less high demand? But it really is based on the structure of the curriculum, not necessarily student demand, what kind of AP courses or those kinds of things that they come in with, what ideal combinations of courses exist. So a student could use one of these maps as they are sort of off the shelf to figure out what their course schedule might look like based on the requirements, but that doesn't necessarily mean that that's going to be a healthy schedule for them to have. They may have the 5 hardest courses possible at the same time. That's not a great thing. So things like schedules and predicted enrollments and ideal paths are something that we want to know about as faculty and advisors just as much as the students do. We want them to do well through these pathways. And so illuminating these things are kind of what we're thinking about when we're thinking about ideal maps. So it's not just the map, it's the map enriched with information around the combinations of courses, when those courses are typically offered, and what the students are generally feeling as far as the order that they take these courses in for what's ideal and the actual data that supports it. So basically taking the anecdata that we have from them about the combinations of courses and also using that in conjunction with the data we have from massive amounts of students taking these courses together for what actually shows up as being beneficial or harmful in terms of the GPAs that they end up getting at the end of the term. So what we're thinking about doing here with this team, and this team is new as of this term, is literally mapping out the curricula with our partners. So there's several partners that work in conjunction with these teams to look at what are the curricula in place. So they're talking to advisors, they're talking to folks on the education side of things, looking at what's the order of classes that they have to go in, what are all the options for prerequisites and that kind of thing. And then taking data from DegreeWorks. So DegreeWorks on this campus is a place where you can get out information about the courses students take, when they take them, and how well they do in them. So we can take that data and map it onto the course maps to get an idea for what's the ideal order to take these things in. What might the demand be in a couple of terms if everyone is coming in with a certain amount of AP credits, for an advisor to say, okay, in the springtime, this course is going to be difficult for you to get into. Maybe you want to plan on a plan A and a plan B, that kind of thing. So they get this DegreeWorks data, extract that back out, know how students are doing, know what could be suggested to them in terms of what they would enroll in, and then look at some ideal combinations for what would be best long term for their trouble spots that they might encounter, say in their junior year, but we can see them ahead in their freshman year. If they want to study abroad, they can know which semesters might be most ideal for them to do so. If they want to co-op, same idea. They would know which terms would be better for them to go abroad in so that they can still get the classes that they need, graduate successfully with a great GPA, and then incorporate all those other ideas. So the students are currently working on this. It is a massive undertaking to put all these bits of data together. I want to thank my teammates very much so for making the data available to them. But the main thing that I think is something we haven't highlighted yet, but Didier did just in part, was thinking about what the students gain from this. So selfishly, they gain a little bit of information about what their GPA and that kind of thing, and those ideas that are in place for when they're planning their schedule. But another thing that they start to realize when they work with these massive data sets is how much variation exists in data sets and how to account for it. And what do you do with gaps in that data? What do you do with information that isn't totally complete? So if a student is gone for a semester, what does that mean? How do you handle that in your data set and that kind of thing? So thinking about disambiguation, thinking also about variation in data sets, thinking about how to marry those data sets and what those pieces of information mean. GPA isn't everything. So what are the students conceptualizing as GPA? And how does that lead to how you build your schedule? I think this gives them a richer idea of how data sets work, what that information can tell you and what it can't tell you. And so that's one really great thing I think about the VIP. So I'm going to turn it back over.
So, I'm a glutton for punishment, so I'm sort of trying to manage multiple teams this semester. And one of the teams that I was kind of the generator for a user story is around AI. It's constantly something that we're constantly talking about. I think internally our teams are looking at how do we incorporate this into our processes. And so I wanted to kind of bring that to the students to see what kind of topic could we potentially use AI to sort of bolster some of the things that can potentially help them. And the idea that we had is maybe an AI course chatbot, right? And initially, the concept around it was really grand. I want this. We would like it'd be great if we could have this chatbot that could tell you everything. But we finally sort of settled on what if we could use some existing information about courses to help students understand maybe the rigor, the time commitment for a course, some information that is already there in print, meaning the syllabi. And so this semester, students are looking at how do we take a syllabi and build it into a chatbot to help students get a better understanding around the time commitment for a course, dates for a course, things of that nature. And so that's where we've started with this team. They've organized themselves really well, and I like how they've gone about it. You have one team that's purely focused on doing research and data acquisition, and because we have faculty in our class, they've been nice enough to offer up some of their syllabi to kind of get this started. And we're thinking that maybe this can be sort of an opt-in approach where it's not like we're going to go out and grab everything. We're looking at how do we set up a process where if you're a faculty and you want to opt into this, it can be as simple as uploading your syllabi and automatically sort of provisioning a chatbot for your particular class. Because we do want to be, sensitive and, ethical as we approach this. So that team is looking at how do we, consolidate syllabi? How do we tease out information in the syllabi? The second team is UI and UX. They're looking at how do we develop a prototype similar to the Provost team that built out wireframes. They're looking at how do we make something that's visually usable, easy, pleasant to look at. And then the last is the back end development team. They're looking at different options in terms of technology, one of which is the Azure Open AI Studio. It's a really great new tool that's being offered that allows you to kind of make the transition to use OpenAI really easy with your own documents. They're also looking at Azure AI Services, which is sort of a developer toolkit that you can use to sort of bootstrap your own chatbot using some of the Azure AI services. And then, of course, you have Python, which is a great tool for just kind of quickly iterating something from the ground up. And as we mentioned before, many of our students are already sort of kind of in the deep end in terms of software development. And so I think this team has attracted a lot of attention. When we first talked about it in the first day of class, I was surprised at how many hands went up that wanted to be on this team. And I'm really pleased at how this has kind of developed over time. So just to give you, we don't have any visuals because it's the first semester. So just wanted to kind of give you some screenshots of some of the tools that they are, looking at. This is a screenshot of Azure's OpenAI, a chatbot service where it sort of allows you to quickly spin up something to test what it would look like. The next one is their developer toolkit around using Python to integrate many of these services that Azure have. And it's likely that they may look at creating a React app, like a web app that uses these functions, or they may look at something else like maybe a Power Agent in Microsoft, because we all use Teams and there's a lot of ways that we can sort of integrate it. So they're looking at different ways to sort of approach this. All right, I'm going to bring the rest of the team up and to talk about lessons learned. I can give my brief thoughts on it, of course, and I'll pass it to everyone else. So lessons learned. This is my second semester in this class. I used to be on the sidelines helping Lou whenever he had data requests, but I think it became clear that I'd be in a better position to sort of help these students if I was actually interfacing with them on a weekly basis. And so one of the lessons that I've learned is first and foremost time commitment. This is a time commitment, and I've learned that I've got to do a better job of sort of managing how I relate to the students, how I work with their schedules. Because I'm in IT, I kind of sit on the side. I don't typically interact with students. And so this has been a really fun opportunity for me to kind of see how bright our students are, how ambitious they are, and how open they are to try things. And so that's one of the things that I've been most excited about, just learning how great our students are. So I'll pass it on to anyone else who has thoughts.
This magic stick. So one thing that I really like is I'm typically on the student end of things, but I am not usually interfacing with students that are outside of biological sciences, which is my home department. And so I teach statistics there, I teach data science, those kinds of things, but I'm not teaching it from a sort of computer science background. And so I think a lot of the students in that space are very good at being able to do stuff and try and to see what sticks, but they have less so sort of the background of why. And so I'm constantly going, what, like, yeah, I would say in biology, what's your hypothesis? Or here I'd go, what's your aim? Go back to the user story. What is the thing you are trying to do? Because they are very good at being able to play with things and get things to do stuff, but sometimes lose focus on what is the aim that I'm going for. And I really want them to focus in on, you have a goal. Think about that goal. How are you going to get there? And sort of reverse map that back, not just in technical skills, but also how are you going to work with your teammates? Because they're always working in teams. And sometimes some students may need more skills in that space. And they're in this particular class also with the benefit of VIP having the experience of getting to be the older student, getting to be the more senior student on something. So they may actually be sort of in a more supervisor type role or a more seasoned role, and getting to see how their skills develop as well for mentoring other younger students in that space is also really great, and something that I've been pleased to see and help coach them through.
So in terms of lesson learned, right? Some of the things has been interesting is to learn what it means, even though I had previous experience working with students. I think it's important to paint a picture that this is only a 1 or 2 at most credit hours for the students. So the students typically are not going to be able to spend a lot of time on the project. And so you have to kind of, coach them, mentor them to level set objectives that they can accomplish at the end of the semester. Another piece, which is very interesting about VIP because it's project-based, is that, this is not like every time that the class is done at the end of the semester, so you kind of reset. The program allows for students to come back multiple semesters. And so it's been very interesting to see the dynamic because you, kind of gauge the engagement and the appetite for from the students for this kind of class by how many students are coming back. What was very surprising for this semester is that we have around 32 students, right? 32 students, right? For this fall 2023 semesters. Out of 32 students, 24 came back from spring semesters. And we have, I don't have the count, bad on me, I should have had the data before talking about it, but we have at least more than 50% of the students that came back from more than 1 semester. And so you have to learn that continuity, how you work with it, and how now you also mentor the students that are returning for themselves to become mentors to the new students that are joining. It's also important to help them from an agile or lightweight project management to say, hey, at the end of the semesters, think about what you need to document. What kind of materials and artifacts are you going to have so that when you have new team members, if it's end of spring, coming back on fall, what kind of materials, what is your plan to onboard new team members? And so really these are projects that you don't think about the projects or within a semester or 2 they'll be done. We've had projects that really happen over multiple semesters, and Lou, maybe you can talk about some of the projects that got sunset, in particular the one of communications, because we reached an end. Lou?
I'll just say a couple things because I think we should leave some time for questions. But yeah, echoing everything my colleagues said, that's all true. It's this is the kind of work that students don't normally find in a traditional Georgia Tech curriculum where they're working hard to learn theoretical concepts and do calculations and run labs and collect and analyze scientific data or write research proposals. All that's part of their daily life. When they're faced with this project where there's a team and it's messy and there's people who aren't doing the job that you think you're doing because you didn't really tell them what you wanted them to do, and all the things that are sort of more real world type of activities, the students find that to be, some of them just naturally take to it and some of them find it to be challenging. So, what the Institute Communications was one of the teams that we had a few semesters ago. They were looking for particular analysis of some data or some dashboards. Our students put it together for them, and then that project was done. So it's actually kind of nice to have this ongoing flow of students who are interested in data and interesting research or institutional data projects that come together. And we can't always do everything, but it's valuable to the students, and I think it's valuable to the institution. So, well, I guess we open it for questions. Thank you for your attention. Now it's your turn to talk.
And we'll throw this out too, to give a plug. If you're interested in helping out, some of you all are on my team or I work with you, so you've sort of been co-opted. But if you're interested, please reach out to us. We're always looking to collaborate with folks. We've started this semester looking at maybe potentially collaborating with other VIP courses that have sort of tangential interests as well. So if you're interested to help out or just learn more, please feel free to reach out to any of us on the team. But with that, we thank you and we'll open it for questions. And if those of you who are online, if you have questions, please drop it in the chat. I have my phone here, so I'll try to make sure I check that as well. But anyone in the room, please feel free to ask any questions. And if not, we'll do what we always say on Teams.